Hello and welcome to the channel. So we're looking at part 2 of this Stromberg Carlson AU57. If you remember, in part 1 we just did a bit of an assessment with this amp. We just run it up, and if you remember, it was extremely noisy and we found one or two problems with it. So now I'm kind of delving into this amp a bit deeper because there's things that we need to sort out, and a lot of it is unfortunately some safety stuff. All this gluing thing that's going on in here apparently is down to a UK tech and not the guy that fitted this transformer when it came from the States. This transformer, this was fitted in the States, and in part 1 we'd noticed that we had an extra winding on the previous transformer with a 6x4 going on there. Let's have a look at that on the schematic later. So that transformer's been removed, and this is a 240 volt transformer. Remember, I'm in the UK, so we're 240 volts over here. So we've got this transformer, and I think it's a classic tone if I remember. With that, I've not really had the lid off. I've just got this propped inside the lid now, the lid on, and I've just got it upside down, which is why I've got a bit of a lean on it because of the handle, but it's holding up nicely. So I thought we'd look at some of the things in here that really need to be changed before I can even start to make this amp quieter, and then mod some of these channels and do one or two bits that the customer wanted doing. One thing I have done already is remove this XLR that was on one of the channels, so that's already removed. Now these jack sockets on here, if we look, they're not switchable, and so what happens is, so that, you know, guys playing through one channel, the other three aren't down to ground, you know, then, because the idea of a switching jack socket is when you unplug it, it switches it to grounds it out, it gets rid of the noise. So you're going through channel, say channel 2, but channels 1, 3 and 4 are just open, they're not grounded because these aren't switching sockets, so they've got to go. That's the first thing. Now let's have a look at some of the things inside, and it might just need a light to go in to see odd bits and bobs. So if we look at the bypass capacitor in there, if we just go in, you might be able to see that the cathode bypass capacitor is glued to the 10 watt cathode resistor. So what was the problem there? Well, the problem there is that, and I'll point that out here, the problem there is that gets red hot, so that capacitor there is obviously being baked, and it's already the original capacitor that was put in the late 50s. I think this amp's from about 1957, so that cap will be absolutely baked with being glued to that resistor. And you're kind of just thinking, why have you done that? Very strange why someone would do that. You know, we all know that capacitors and air heat is a no-no. So why glue one to a 10 watt resistor? There will be some heat being dissipated, hence why it's 10 watts. You know, there's two 6L6Bs running on there. So yeah, that's got to be changed. We've got to try and piddle the glue off that 10 watt resistor, because I don't really want to be changing that unless there's bias issues with the amp, and there may well be, because the transformer's been changed and that's still the original resistor. It may well not match up to the voltage this transformer's giving out, we don't know, but anyway, that's by the by. But the main thing is that's glued onto there, so that's got to go. And so if we look in there, can you see that now? I've got the macro lens on there, so you should be able to see the glue there. You can see that on there is glued. Probably a bit too bright now, this light, but so that's so that's got to be changed and sorted out. What else? So if we come back here, we can see we've got two capacitors glued to a large bumblebee capacitor there. You can see two radials glued together and then glued to a bumblebee cap. All these bumblebee caps have got to go as well, because they're all leaking. If you remember in part one, we tested these and they're all leaking DC. So they've also got to go, so he'll have to go as well. But that's, yeah. And then if we look across here, if we go in just a bit closer there, can you see those four resistors all glued together? Now, I think the logic behind gluing those together is because while they're moving around, these leads can touch together on other things, although at this moment in time I don't really see what. And it's easier to insulate them rather than just glue them together. Well, actually it's probably easier to glue them together. And look what's happened there. See that resistor crack? Because they're old. So you can just see I just lightly pressed against that and that's just dropped apart. So that could be the glue corroding the resistor, or it could just be that the resistors are old. But anyway, that's a bit of a no-no. That's been done there. It's also been done there on those four more there. Look, so those again they've all got to be changed. So now if we look in here, you can see we've got some original capacitors in there, so they need to go as well. Now moving on to these CAN capacitors. These CAN capacitors are not being used in this amp apparently, and from what I can see they're not, other than these are being used as ground points here. But you can see that this is all loose, so they've used the grounds on the CAN cap there, but that's just all, it's cracked there, that's all loose. They've used the 6x4 socket as a ground point as well. There you can see as a ground point, which again this is riveted on, so it's a bit of a no-no that is as well. So we need to change that. Back to these caps again. So just looking at this, and I can't, the top's on it, so I can't afford to get in and wobble them, but you can see that was broken. So that's all got to be done. And really, you know, I don't understand why they haven't just took those caps off, drilled the rivets out, and then just put some brackets on and put a couple of CAN caps on there, which would have eliminated this, and at least these two, really, because we'd get four in each two in each can, so that's four, so that'd get rid of four of those. So that, and then that would only leave, and there's only two more in it besides that look like electrolytics. There's only two more in it, which are those two over here, you can see there. Which is what I might do, because this is only a 22. Now I've looked on the schematic, sorry, I've looked on the data sheet for the rectifier tube, which is, I made some notes somewhere, which is a 5DJ4. That's the rectifier we've got, and the split, the winding on each side of the center tap is 25 ohms, which is a total of 50 ohms. So 25 ohms on each side of the primary, which according to the data sheet says we can use a maximum of 40 microfarad on here. Well, we're not going to get 40 microfarad cap, so I'm going to put 33 in there. So I would prefer to have something bigger in there, but don't want to be pushing that more than the data sheet says, because these tubes are obviously, they're expensive and they're getting scarce. So we'll put 33 on there, and that should be most delightful. So that should reduce us some noise. This screen capacitor here that's been glued down, and you can see this had also been glued to the side, but that's since come off, and that's been glued down, so we can't see what that is, but I'm guessing more than likely, well, there's one thing, it won't come off there, will it? As they say up our way, it won't come off. So we need to look what that is, but we'll make that a 33. And I think best thing to do is put those in these cans, that you know, take these cans off and try and get a 33 in there, and maybe even 33s for these two. Don't know what these two are actually. They are 22s. So I'm guessing that's a 22 on the screen. They all look like 22s. But I think on the schematic they were 40. Let me just have a look at this. So we've got a schematic on the lid here. Just have a look on there. We have 30 microfarad, sorry, not 4. Yeah, so we've got 30 microfarad on there. Yeah, so we're just going to use 33s in there, and that'll be fine. So you see I've got those off. I've got both of them off now. You can see some of the paint missing around here because the old ones must have been loose and they've obviously tried to glue them on. Maybe they got, because they've got, where's that cap that I've just ripped off? They've got the ground lugs on there, and we're probably getting intermittent ground, so they decided to glue. It's here. So they've probably tried to just glue them down, and you can see that they left the resistors and everything on there. It's a bit lazy. I mean, if you're gonna have these as not used, at least don't connect anything to them. But anyway, that's off, and these are 30 microfarad at 500 volts working, and you can see where the rivets went through for the previous capacitors. We've got that. We can mount that there. Can we just get away with that? Now the problem as well that we may find here is that the lid might catch these as it goes down, or it might not even go down. It looks like they're going to fit, but they may not. Now if they don't, then we'll have to turn them that way and re-drill the holes again. But I want to use these brackets because obviously they're very secure. I don't like the way that these type of things are done. They're always loose and flimsy. Well, they always work loose eventually. So we want these to be good and solid. But we'll try them that way. I'm just going to fit one and just see if the top cover, because the top cover is like a cage that slides over this amplifier. Right, there we go. That's how they're going to be. The lid does go down okay. I've done a bit of work on this Masco, and it's a swine to get in, so I've had to take this pot out to wire those caps up because it was so difficult with the iron. I was starting to catch the insulation on the sides of the birch burnt that slightly there. Not detriment, but it just doesn't look very tidy. Just trying to squeeze in, so I've just taken that out. It's out of the way now. So I'm using this wire, this cloth wire. We've used this before. It seems to work well in these amps. It looks the part. So I have removed the screen capacitor that was, and there it is, and you can see it's been glued down with such ferocity that we've left half the capacitor and the glue there. We've got to scrape that off, so that's gone. And you can see here I've disconnected the resistor, the bias resistor and the bypass capacitor for the output tubes. That's an old Stromberg Carlson capacitor, but I'm afraid that resistor's no good now. It's caked in glue, and we're going to get rid of this socket here that they've used as a ground lug, and here's the center tap for the HT voltage. Just, you can see that's just on there. Well, it's just dreadful. So that's just not good at all. So we need to get rid of that. So we click that there. So we know that's center tap, and then we've got that totally disconnected. So we're just going to drill through the rivets on the other side, pop that off, and it's out of the way. There's no point in that being there. No one will ever get confused in the future and plug a tube into it. Not that it'd do anything, but even so, it doesn't want to be there. And that lot is a right mess, so we've got to try and get, I think I'm going to have to soak that with some alcohol to get that off. But we're making progress. Now we're going to put some screen resistors on this amp, on the output tubes of this amp. So we need some tag strips, because this feeds the screen. So you connect this to the tube, but then you can't have you've got no screen resistors. So what you do then is you then connect the screen resistor on and connect the wire to it, and it's wobbling about. Now that would be okay for some things, but not with that amount of high voltage. It's probably not a good idea. So we need to do it right. So we're going to have to drill in and get some proper tag strips on, so we can then fasten from the tag strip to the tube with the resistor, and that'll be a much safer way of doing it, and more reliable as well. So I'm going to go off and investigate now if we've got a 250 ohm resistor. We'll have a capacitor somewhere, 50 microfarad, so 47 will do for that. Check that out. That's just what we need. A 10 watt 250 ohm ohmite resistor. He will be replacing him, so we can have that removed, and the job is a squirrel. Right, so we're looking in this Stromberg Carlson, and I've got a centre tap here, and I've got a wire here down to the caps that'll feed to the anode, the cathode on the rectifier tube. This is the screen feed here, and we're going to go to pin 6, and then we'll use a screen resistor to pin 4, because this amp's got no screen resistors on. So we've got that there. But then when we come to this tube, pin 6 is occupied with a wire coming out of the transformer, and I'm wondering, is that negative feedback? So let's have a look what's coming off this side then. What colour is that wire? What colour would we say that wire is? Grey? Have we got a grey wire? There, grey. So grey is coming off the 120k, and that's going all the way around here to this cathode. So that is negative feedback then. So our pin 6 on that tube has been snaffled for the negative feedback. So it's 120k there. So that's our negative feedback on pin 6. So what do we do with this then? Well, we could connect them and just shrink tube it. It is only negative feedback after all. Now we've also got no grid stoppers on this amp either. Got a grid leak. We've got 47 nanofarad these here. We've got another wire broken here that we don't know where that goes either. Yes, it's going to be fun, this one. We'll get there though. We always get there. Perseverance is the name of the game. Right, so we're plodding on with this now. I've got the grounds in now for the centre taps down, grounded to the chassis. Now I've removed the 2 capacitors that were wired, looks like they were wired in series, and they are here. As you can see there, they were glued onto the side of that Bumblebee, and the Bumblebee now has still got, although it's leaking anyway, but it's coming out, but that's now got part of the capacitor covering stuck to it. Now I've got the screen resistors are done here, and just got this negative feedback to connect back up that we took off of pin 6. This is the drop-in resistor for the next stage for the phase inverter, which is 22k, but it shouldn't be quite that big. I forget what it is on the schematic, but it's not that big. Might be 15k. But I've now mounted the drop-in resistor here from this node, which is a much better way of doing it, and I've also upped it to 2 watts. And I've dropped it to 4.7k, and the reason for that is we only have 359 volts on this transformer, which is not generating as much as the other one was, which is about 80 volts light. So, and if you remember in part 1, if you've watched part 1, these 12AX7s had hardly got any voltage on them. They only got about 30 or 40 volts on them. So obviously part of that is because this resistor's been increased, and part of it is because the transformer isn't as powerful as the other one that was on there. So we need to get a bit more voltage to those tubes really. So those 2 caps were soldered onto here, and I've removed them, and now I thought I'd test these plate resistors here before we these 150k plate resistors. And I'm beginning to wonder, you know, if this was a kit or that someone's built, because if you look at a lot of these resistors here, there's just no insulation on any of them. And if you look here, this 150k resistor is virtually touching the grid, because that's the plate there, pin 1, that's the grid. So that means that we're going to end up getting plate voltage on the grid of the tube, which is obviously not going to last long. So these should be insulated. You can clearly see that we're virtually pushed down on there. So I've also, let's just measure these as well. So I've got to be very careful here, because there's potential for quite a few shorts, and obviously not that that would be a short if it went onto the grid, but that voltage, but certainly the tube wouldn't be long before it said good night. So let's just see what that is. We ought to change these anyway because the carbon comp. So you can't see that, can you? Whoops, fail. So that's 161, so that's drifted anyway, and the other one is there, and that is 100 and what? Oh, yeah, 161k. So what's this one? 182k. So that's drifted even more. So they need to be changed. Now I haven't wired up, as you can see here, I haven't wired up the rectifier tube yet. The customer said he would like, if possible, a IEC socket put on the back here. Now, as everyone knows, this was originally an 110 volt amp, so if it still had the 110 volt power transformer, that would be a no-no, for the simple reason you couldn't risk plugging 240 volts into that. But because this has now been converted to 240, we could. But the only thing is, and I've got one of these bulging ones here that you just drill a hole and these will fit in the hole when you don't drop it on the floor. So it's just a matter of whether we can drill that hole and it doesn't end up too far to the top here. That's what's bothering me with that. So I'm sort of looking at that and plucking up the courage to do it. But so that's why I've not wired any of this up, because I'm going to have to get all these wires out of the way, so I might as well not bother soldering them up if I'm going to do that. See, down in there. Now I'm also going to make a solid state rectifier for this amp to power it up with, so we can power it up from small wattage bulbs on the current limiter, and just check for any shorts. So, and I'm going to do that. I bought these tube-based sockets, tube-based plugs rather. So what we're going to do is wire some some diodes into there, and then this will just plug in, and then we can just power this up without having to shove so much voltage into it to get the rectifier to work. So that's that. So the next job is to wire up this node here. So that's the third node, and then we've got another node on another capacitor in there, because it's 50 plus 50, remember, and that will bring us down to here, to this one here, and then this last node we're just going to have to put just a 22 on there, in there, because we can't leave that. So that's where we are with this at the moment. So we're plodding on slowly, and I'm nibbling away at this amp between other repairs and at night when I've supposedly finished work, but to keep having a nibble at it. Right, so we've been doing some work in here, and boy oh boy is this turning out to be a poo fest. So I'm working through this power supply, and I just keep finding more and more things with this amp. It's like a kid's worked on it. It really is. The amount of, no insulation on any of these, and so we've got the caps in here. We've come round to this point here, this drop-in resistor, and there's a capacitor for smoothing that there. Then there's a wire going off there, you can see, and then that goes on to the to feed the phase inverter from that 4.7k dropper. Feeds the phase inverter. So that in effect is the smoothing for the phase inverter. We've got a couple of 150k resistors here, which I've had to change. One is they're just all, the leads are all screwed up. There's no insulation on them, and getting them off here is a nightmare. And you can see why people J-hook these, because it's time consuming getting the wire off the pins, and especially without breaking them, although I've not broken one yet. Then we've got a resistor, drop-in resistor going over here, and then we've got another drop-in resistor coming back and going over here to this bunch, which is obviously, these have had it. I mean, they've glued them all together, so they're all done. A lot of these resistors are out of tolerance, and then we've got such as this here. This is a grid leak, and you can see how that can just touch onto there. That's voltage, that's the plate. Things like that you keep finding, and you know that shouldn't be. These need to be insulated all round, really. I mean, there's one thing if it, you know, if it can't touch, because but that can. And then we've got this where it can touch again across this capacitor here. You can see it's just a mess, and I'm just going through this trying to sort it out, and I'm just gonna end up practically rebuilding this amp, because there's just things in here I can't leave. Another resistor there, 270k there again. Those three there, now those two come from the same point, so that's okay, but that one can touch this one, and that one obviously can touch this, so it's just a mess, absolute mess. This was a mess from the day it was made. A lot of 150k plate resistors. I've got about 5 or 6 carbon comps. I've got some metal, carbon films. I've got some metal films. I've got no more carbon films. There was no screen resistors on the, there was no grid stoppers on the output tubes. There were no screen resistors either, but you've seen we've already added those. So we've got grid stoppers to make these up. So we've got 5.6k grid stoppers on there. We've changed these 47 nanofarads. We had these ones before, but they were leaky, so we've got rid of those. And this now we'll wire to here from this, back from this drop-in resistor here. We're going to wire back to here we're going to remove this one because that's just, well, words can't describe that mess. This is the other 50 microfarad in that can, and that will smooth here, which will then smooth these two nodes here. And then we've got two more. We've got one here and one here, which we're going to have to address. So just looking in here on a few resistors. So if we look at these resistors here, this is the tail resistor from the phase inverter, and that should be 4.7k, and you can see that's 5.2, so that's a good bit over, so he'll have to be changed. There's also another one up there, and that is 5.4k, so that's should be 4.7, so that one's got to be changed. This one here measures 161k. It should be having a bit of problem getting that in here. Slide it across. So this one here is 150k. That's showing 161, and we've got no insulation on there, as we pointed out before, so that's got to be changed. So let's just see where we've got to then. So we've got, this is the phase inverter, which we've now finished. We've changed the plate resistors. These two, the tail resistor on the phase inverter was miles out. That's 4.7k. That was well over 5. That one was also well over 5 going to ground there from the tail resistor. We've got this node is now wired up here with this 6.8k, and I have dropped some of the drop-in resistors because we don't have as much voltage on this transformer. We got very, very low plate voltage on these channels, so we need to get that up a bit. Plate resistors changed on this stage here, and this stage here is where all the bass and the treble is. So a couple of things. So the treble pot has got the on-off switch on there, which is going to induce noise. And this is one of the problems with this amp, reducing noise. So we're going to put the switch on the back of the amp there. We've already got the IEC in there. We're going to use it, we're going to plate this, and we're going to put the switch there on the back of there, and then that removes that. Now a couple of things with this control. This treble control here is damaged there, and this amp's had a wallop on the front. Now remember when this and I've actually got that in the on the test bench, this had a different knob on there. It had a chicken head knob on. You can see on there, and I couldn't really see that until I actually took the pot out, and I had to take the pot out to get these caps in because I couldn't get in with the soldering iron, so I just took this out. But if you look there, it's all dinted in, so that at some time, and it's like, whatever's hit that must have been pretty tough, because this chassis is quite thick. It's, you know, that's not just been a tap to do that, that's been quite a force, and you can see the paint's flaking away around there because of that. And this pot has got a tight spot in it when you turn it up, so I'm guessing it's damaged it. Probably still works, but it's not great. Now the other problem is this pot is 5 meg, which is a very strange value for a treble control, and the bass pot's also 5 meg. So we just turn around on here, which brings us now to the actual wiring of these pots. So we've got to find a 5 meg pot to go in there. We've got the bass pot here. We got 2 caps on here. One is a 4.7 nanofarad, and the other one should be a 470 picofarad. And I measured that, and it was 374, so that's quite a bit out. The other one, the 4.7 nanofarad, a bumblebee, so we changed that anyway. Now we've got this broken resistor here, and I've worked out on the schematic that this is, if we look, I won't be able to see it very well on here, but this is base control further across. Base control is here. It's a 47k going to ground. There's the 4.7 nanofarad, 47k. You can see that's where the 4.7 was connected there. So that's 47k to ground. That disintegrated when we was taking this lot out. So he's got to be done. Right, so we're going to connect this last node up in this can, this last capacitor here. We need to bring a wire down to here, and this is the drop-in resistor here, which I've dropped 5.6k from 10k. This goes into here. We're just getting a bit closer. This goes into here, and that is feeding this glued up mess here, which is this tube and this tube, and then we've got a 33k drop-in resistor here, and that goes on this wire here, if you can probably see it, and that wire goes up to there, and that feeds this block of glued resistors, which feeds these two tubes here. Now this cap here is on a red wire there going to here, so we don't need that because we're now using that capacitor there, so he can go, and he just needs replacing with something a little better than the Zebedee boing boing cap that we've got there. Right, we've done a bit more. We've got the base control wired up now, all this here, and yeah, another coupling cap gone in there. Few other bits, that's got to still be fitted. So worked his way through. It's getting rather complex now, getting into all this, how this is wired to the schematic. Bit of a strange circuit. There's not one I've ever come across before. Now we need a 5 meg pot for there, and I'm going to have to order one. I've had a look, see if I'd got one, second-hand one, but no, I hadn't. I know I'd not got a new one, so we're going to have to try and find one of those. So let's just have a look at what we've done now. So we've got a switch on the back here, and if we just go in, you can see a switch and a fuse on there. And I have put this on the outside, and the reason for that was because we'd had that AC inlet, AC outlet thing on there, and obviously there was a square hole drilled there, so I made a decision to pop it on the outside, put the switch there, fuse, and I just need a spring, I just need a washer just to go on the back of that before I fully tighten it up, and then we can wire that up. Now I've wired this tube up here, which is for the tone stack. We've just got this, which should go on there, but now we've reached a point where we're going to be looking at these channels, and you can see over here I've stripped out quite a lot more stuff, that those sockets that were no good, and we need to look at a way of getting the new sockets fitted on more securely than these were done. I've stripped out most of the wiring on these sockets here, and these are for these plug-in high and low impedance things that we're not going to use on this amp. I've removed in this corner here, I've removed there was a rotary switch on there which was magnetic, or just says Xtal on there, or mic, so that's been removed. We don't need that. So now it's just down to the channels. Now technically there's 4 channels on this amp, but I'm kind of thinking one of them's not that good anyway, the way it's wired. These channels all mix into this 2B, in fact into that grid where you can see that old 100k which will be removed. But they all mix into there by the look of the schematic, and I need now to study this schematic. I need to contact the customer and have a chat with them on how we're going to do all of this channel thing. And on the front here, if we turn this round, you can see on the front we've got the treble and a very dinted front panel there. We've got the bass, microphone 3, 2, 1 and input. That channel's not really up to much, so we need to look at that and decide whether we're actually going to keep that channel. I mean 3 channels is enough really, but in the end that decision will be made obviously by the guy that owns it. If we look at the side now on here, just go down, so now you can see the way that these have been placed, and they've been sandwiched to get, just sandwiched a couple of these either side to put the sockets in. So but I've noticed that we've now got 3 holes there, so I think what we're going to do is we're going to bolt them in like that, which is, to me, looks a lot neater and tidier. So we'll have there and there for those three channels there, or we've got mic 1, mic 2 and mic 3, but it doesn't really matter what goes where now. We could just use those 3 there, it would make more sense, and then just plate this one off and maybe even put something else on there. I don't know. Does this amp want a master volume? I don't know, and again that's, you know, doing away with the channel then leaves us with an extra pot to make a master volume on this amp, so that's another option as well. So plenty of options. Not quite finished, just go over, not quite finished off wiring all this power supply section as we're getting into the preamps now. Let's just turn it back around again. So, and there's just one more capacitor to go off on, and that just that one node when we decide really where we're going to go with this. Well, I would say this is probably about half finished now, but there is still a lot of work to do, and obviously there's a lot of components to remove as well. We've got you know, 4 resistors there glued together, 2 more glued together, so they've just got to go. All the bumblebees have got to go, and you can see we seem to have more room now with removing a lot of these bumblebees. There's 2 over there, a bumblebee there, and another cap got to be changed, but I've left those on till we get the tone, the treble pot. So I managed to find a 5k treble pot that's coming from Mauser, so but we've got to wait for that obviously to be delivered. So yep, still quite a bit of stuff to do on this amp, but we are getting there. So what I'm going to do is make this a part 1 now, and I'm going to contact the customer, have a chat with him, decide where we're going to go with these channels, and then from there we'll strike up part 2. So that's going to do it for this one. So no guitar playing on this one again for all you fans that love the guitar playing. Obviously you can see that there's certainly not going to be any on this video. So I've still got a lot of comments to reply to on the channel as well, and I'm trying to get through them between this and other things, and I have got some repairs coming in that I've got to get done this week, 1 or 2 repairs, which, so I'm going to drop onto those while I'm waiting for parts for this, and mulling over a few ideas of what to do with these input sockets and the channels and so on. So if I've not replied to your comment, I will try and reply to it. It is becoming more difficult now, simply because I'm just getting more and more of them as the channel grows. So that'll do it for this one. So thanks for watching. You all take care, and I'll see you all in the next video. Bye bye for now.